Hi everyone, so today we are talking about the idea of slope and finding slope specifically from a graph. So we've talked a little bit about this, so today is going to be a little bit of a refresher and some new stuff. So slope is defined as the rate of change of a function. So that would be the change in y divided by the change in x. We've talked a little bit about this, but these triangles, delta, stand for the change in. So the change in y divided by the change in x is equal to the slope. So if we were to look over at this graph over here, I could start from this point, and I could try and get to the other point. So the change in y is 1, 2, 3, 4, 5. So I went up 5. And the change in x was 1, 2, 3, 4, 5, 6, 7. So that'd be a positive 7. So my change in y is 5 divided by my change in x, which is 7. So my slope is 5/7. We're going to go a little bit deeper into that, but that's just a little start. To find the slope from a graph, it is helpful to find lattice points. So now lattice points are specifically points that hit 4 squares. So if you're looking at this right here, that would be a lattice point. It hits 4 squares. This one only hits 2 squares, so it is not a lattice point. This one also only hits 2 squares. This one hits 4 squares, so it falls perfectly. These points cross the grid of the graph perfectly. In my class, I used an example of looking at the tiles on the floor, and if you put your foot in between 4 squares, then you would be at a lattice point. Then you determine the change in y and divided by the change in x. Okay, so let's actually take a look at what this looks like in practice. So here are some examples. Example 1, 2, and 3. So again, I'm trying to find some lattice points. So those are points that hit 4 squares. So this right here, I see as a point that hits 4 squares. This one is not. This one is a point that hits 4 squares. This one is not, and this one is. So between those lattice points, I'm going to try and find the change in y and the change in x. I'm going to be creating that slope triangle. So if I was to go from this point to the level of the next point, that would be positive 2, and then it's over 1, so that's positive 1. So again, I find my change in y divided by my change in x. That's going to end up being positive 2 over positive 1. So when you divide those, you get a slope of 2. Okay, if you're looking at this second example, you're going to try and find these lattice points again. So I see one lattice point here. This is not a lattice point, it only hits 2 squares. Only 2 squares. This is another lattice point, only 2 squares. So those are the only 2 lattice points that I see. So again, I'm going to find the change in y. In this case, I'm going down 1, 2, 3 spaces. So since I'm going down, it's going to be negative. And then I go to the right 1, 2 spaces. So my change in y over my change in x. So that's going to be a negative 3 over positive 2. Now I can rewrite that as, so that's negative 3 over 2, and I can rewrite that as negative 1 and 1/2, or negative 1.5. Any of those answers would be correct. In this final example, I'm going to find my lattice points again. I see one right at the origin in the middle. This is not a lattice point, 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 and I find another lattice point all the way up here. You could have also tried to find a lattice point down here. Okay, so let's see what happens when we actually try to find our slope triangle. From here to get to this point, I know that I'm going to go down 1, 2, 3 spaces, that's negative 3, over 1, 2, 3, 4, positive 4. I can actually follow the same pattern to find the next lattice point. 1, 2, 3, then to the right 4. 1, 2, 3, 4. So I know that my slope is going to be my change in y over my change in x. So that's going to be negative 3 over positive 4, which just simplifies down to negative 3/4, or you could write it as negative 0.75. If you have any questions, please do not hesitate to ask, and that's all for today.